6,000 feet above sea level, in the middle of China's Qinghai Desert, something impossible is taking shape. Massive pressurized domes stretch across rust-colored Earth. Scientists at SEAL suits move through airlocks. Monitors track oxygen levels, caloric intake, psychological stress. Crops grow under artificial lighting in rooms with no windows. The temperature outside drops to -40 at night. This isn't a science fiction set. This is China's Mars Analog Research Station, and it's been operating in near total secrecy for years. While the world watches Elon Musk post rocket launch videos, China has been doing something quieter, something more dangerous. They've been actually figuring out how human beings survive on Mars, not in theory, not in a boardroom presentation, in practice, with real people, real systems, and real consequences when those systems fail. Because here's what nobody tells you about Mars colonization. The rocket is the easy part. The hard part is staying alive once you get there. In May 2021, China's Tianwen-1 mission successfully placed the Zhurong Rover on the Martian surface. It landed in Utopia Planitia, a vast ancient basin in Mars's northern hemisphere, the same region where NASA's Viking 2 touched down in 1976. But Zhurong wasn't just taking photographs for press releases. For 358 days it drove across the Martian terrain, carrying ground-penetrating radar pointed directly at the subsurface, and what it found changed everything. Liquid water, not ancient ice, not vapor. Evidence of water that was liquid on Mars as recently as 400,000 years ago. In geological terms, that's practically yesterday. That's the era when Homo sapiens and Neanderthals were coexisting on Earth, building tools, painting cave walls, surviving ice ages. Mars had wet, chemically active geology at the same moment human civilization was beginning. Zhurong also detected hydrated minerals buried beneath salt crusts on sand dunes, signatures of a planet that held water for far longer than previous models predicted. This wasn't the dry, dead rock. Mars was, and perhaps still is, in certain deep pockets, a world with the raw chemistry for survival. China saw this data and made a decision. They would go there. Not someday, not eventually. Their official timeline lists crewed Mars missions starting in 2033, followed by subsequent launches in 2035, 2037, 2041, and 2043. The first human footprint on Martian soil could land before many of today's college students graduate. But a rocket gets you there in 7 months. What keeps you alive after that? China identified 7 problems. Solve all 7, and humans live. Miss even one, and the mission ends in tragedy. Earth's magnetic field is an invisible shield stretching 37,000 miles into space. It deflects solar winds, absorbs cosmic rays, and quietly saves every living thing on this planet every single day. Mars has no such shield. Its magnetic field collapsed billions of years ago, and what remains is fragmented, localized, offering almost nothing against the radiation that constantly bombards the surface. An astronaut standing on Mars without protection receives 700 times more radiation annually than a person living on Earth. Within months, that exposure begins attacking DNA, increasing cancer risk, exponentially degrading cognitive function, and systematically destroying the immune system. China's answer isn't to build better suits. It's to go underground. Their habitat concepts are based on subsurface construction, facilities buried beneath several meters of Martian regolith, to loose rocky soil that blankets the planet. Martian dirt, it turns out, is a surprisingly effective radiation shield. Stack enough of it above a habitat, and the radiation exposure drops to manageable levels. Chinese engineers have been testing regolith equivalent materials in their desert facilities, analyzing compression strength, thermal properties, and how well it holds atmospheric pressure over time. The surface of Mars belongs to radiation. The future of Mars belongs underground. Mars has an atmosphere. It's just almost entirely useless to human lungs. 95% carbon dioxide, less than 1% oxygen, atmospheric pressure so low that exposed blood would boil within seconds. NASA's MOXIE experiment aboard the Perseverance rover proved something critical in 2021. You can extract oxygen from Martian CO2 through electrolysis. It works. It just needs to be scaled up by a factor of thousands to sustain a crew. China's approach goes further. Their analog stations test closed-loop life support systems, environments where every exhaled breath is captured, processed, and reintroduced as breathable air. Every gram of oxygen is tracked. Every system has 3 redundant backups. Because on Mars, a failed oxygen recycler isn't a malfunction. It's a countdown. The desert altitude of China's test facility, where oxygen is already thinner than at sea level, creates naturally stressful conditions that push these systems to their limits before they ever leave Earth. You cannot ship food from Earth to Mars on a regular basis. The orbital mechanics alone make resupply missions possible only once every 26 months when Earth and Mars align. A colony that depends on supply ships is a colony permanently one failed launch away from starvation. China's solution is growing food on site. Their analog stations run extensive hydroponic and aeroponic farming trials. Plants grown in nutrient-rich water or mist, without soil, under precisely calibrated LED lighting that mimics photosynthetic wavelength. Wheat, soybeans, potatoes, and leafy greens have all been tested for caloric yield per square meter. The Lunopolis experiments, run by Beijing University of Aeronautics and Astronautics, kept teams of volunteers alive inside seal habitats for up to 370 days using bioregenerative systems where human waste was composted into plant fertilizer, plants produced food and oxygen, and the cycle closed on itself. 370 days, completely self-sustained. No resupply. That's not the research paper. That's a proof of concept for Mars. Zhurong's radar data pointed towards something that orbital observations had long suggested. Mars may still hold accessible subsurface water ice at certain latitudes. The challenge isn't finding water on Mars, the challenge is extracting it efficiently and making it drinkable. China is developing drilling systems designed for frozen, abrasive Martian soil, combined with heating elements that melt ice and channel meltwater through filtration systems that remove perchlorates, toxic chemicals that contaminate Martian soil and would be lethal if consumed. Water also feeds the farms, powers electrolysis for oxygen production, and eventually split into hydrogen and oxygen, it could fuel return vehicles. Every liter extracted from Martian ice is a liter that doesn't need to be launched from Earth. Mars averages minus 60 degrees Celsius. At the poles, it reaches minus 125. Even near the equator, a single Martian night can swing 80 degrees in a few hours. No insulation system designed for Earth comes close to handling that thermal stress. China's habitat designs incorporate double-walled inflatable structures with aerogel insulation layers, the same material used in some of the most extreme cold weather applications on Earth, combined with nuclear radioisotope heating systems that operate continuously, regardless of dust storms that can block solar panels for months. Solar power on Mars is unreliable. China is betting on nuclear. In 2023, a Chinese research team published findings from a 180-day isolation study. 6 participants, sealed habitat, no natural light, no outside contact, no variation in environment. By day 90, measurable cognitive decline had appeared in every subject. Reaction time slowed. Decision-making became erratic. Minor interpersonal conflicts escalated into serious psychological stress events. Mars is 140 million miles from the nearest therapist. A one-way communication delay between Earth and Mars ranges from 3 to 22 minutes depending on orbital positions. You cannot call for help. You cannot get real-time advice. The crew is alone in every meaningful sense of the word. China's isolation research is specifically designed to understand this deterioration and build crew selection criteria, habitat design features, and daily psychological maintenance protocols that can preserve mental function for 2 to 3 year missions. The habitat architecture matters. Natural lighting simulation, private space ratios, visual access to growing plants, these aren't luxuries. Their survival tools. Mars' gravity is 38% of Earth's. Spend 18 months in it and your bones lose density at rates that make Earth-based osteoporosis look mild. Muscle atrophy accelerates, cardiovascular efficiency drops. The fluid distribution in your body shifts in ways that affect vision, cognition, and organ function. We know this from the International Space Station, where astronauts in microgravity experience similar effects. Mars gravity is better than zero, but it isn't enough. China's countermeasures combine rigorous daily exercise requirements with pharmacological interventions and advanced suit exoskeleton systems that impose additional resistance loads during surface operations. The goal isn't just keeping astronauts functional during the mission. It's ensuring they can survive the return journey and readapt to Earth's full gravity afterward. Now, SpaceX has a different philosophy. Elon Musk's vision is civilization scale. 1 million people on Mars, self-sustaining cities, full planetary industrialization. The Starship architecture is designed for mass transport, making the per-person launch cost so low that Mars becomes accessible not just to governments and elite astronauts, but eventually to ordinary people willing to make a one-way bet on humanity's future. It's an extraordinary vision, and it may be the right one for the long term. But SpaceX's current survival infrastructure for those first settlers remains largely conceptual. The engineering depth that China has quietly developed in analog habitats, closed-loop life support, and long-duration human isolation studies fills a gap that Starship alone cannot close. You can land 1 million people on Mars. If the air recyclers fail on day 2, none of it matters. Here is what is actually at stake. Whoever solves the 7 survival problems first doesn't just win a space race. They write the rule book for every human being who ever lives on Mars. The habitat designs, the life support standards, the psychological protocols, the agricultural systems. Whoever tests these first, at scale, in conditions approaching the real thing, owns the intellectual and practical foundation of Martian civilization. China is testing these systems now, quietly, methodically, in a desert that looks from a distance like it belongs on another planet. The domes are already built, the airlocks are already cycling. The crops are already growing under artificial light in sealed rooms where the air is recycled and every calorie is counted. Mars is still 140 million miles away, but in a remote corner of China's Qinghai Desert, it doesn't feel that far.